In an interview with CCN, John Woods, Chief Technology Officer, CTO, at the Algorand Foundation, discusses the blockchain's approach to real-world asset tokenization, its progress on quantum resistance, and the enhanced developer experience enabled by the building blocks in AlgoKit 3.0. Speaking from a technical and systems-oriented perspective, Woods outlines Algorand's position in the blockchain space, spotlighting developments like tokenized real estate via Lofty, steps toward regulatory alignment, and upcoming integrations such as MasterCard virtual cards, enabling ALGO holders and stackers to spend assets on everyday expenses. These examples underscore how the network is evolving its infrastructure and focus as it approaches 2025.
How Algorand is driving real-world asset, RWA tokenization.
For Woods, tokenizing real-world assets is a key step in bringing blockchain into the mainstream. He noted that while digital assets have matured, the connection between traditional and digital assets remains underdeveloped. Woods emphasized Algorand's focus on bringing real-world assets like real estate and financial products on-chain. Woods explained how the idea of creating RWA assets represented by tokens means that all of that stuff is done without writing a single line of code. So no-code assets, and that's why Algorand is very accessible to businesses that don't come from a blockchain background. One example is Lofty, which Woods described as probably the crown jewel of RWA tokenization on Algorand. Woods explained how Lofty, as a firm that has pioneered on Algorand the idea of tokenizing real estate. He noted that the platform features some hugely valuable properties, adding, it's not just some shed in the middle of nowhere, there's actually choice. The ability to represent real-world assets like property on-chain, as seen with Lofty, is possible without writing a single line of code, Woods explained. He continued, so no-code assets, and that's why Algorand is very accessible to businesses that don't come from a blockchain background.
Use cases for tokenized RWAs, from real estate to regional indexes.
Woods suggested that the appeal of tokenized real-world assets extends beyond real estate. He explained that there's a number of different things that are ongoing, including crops and other things like that. He described how these tokenized assets could be applied broadly, explaining how you can tokenize property that you own and allow that not just be sold to, say, one participant one hop away, but allow it to be traded or used as liquidity in other contexts such as loans or insurance and many other contexts. Speaking on future possibilities, Woods added, how wonderful would it be to be able to tokenize one's own home or a percentage of it, and highlighted that one could buy California, you could long California and short New York, imagining an index model based on tokenized real estate. For users of RWAs, an RWA trend points to a future where ownership becomes more flexible, composable, and usable whether you're an investor, a homeowner, or someone looking to access new forms of financial utility.
How AI and native languages are shaping smart contract development on Algorand.
As blockchain development becomes more accessible through the use of AI, Woods noted that AI tools are beginning to shape how smart contracts are written. Algorand's choice to support widely used languages like Python and TypeScript makes it easier for developers to get started and for generative AI models to assist. Woods explained how you can essentially talk to any AI today, and it will give you answers that are good in the context of an Algorand smart contract. Unlike ecosystems such as Ethereum, which use language variants like Viper or Solidity that resemble popular languages but differ in syntax and structure, he said. Woods emphasized that Algorand supports native programming languages, stating, not Python-like, not TypeScript-like, it's actual Python, actual TypeScript. This approach reduces the entry barrier for developers and enhances compatibility with existing AI tools. Algorand's decision to support Python and TypeScript was a strategic move by Algorand, as it offers compatibility with the world's most widely used programming languages.
Why Algorand's use of native Python and TypeScript matters in the age of AI development.
Woods touched on the rise of vibe coding, where developers will use generative AI to build applications by describing what they want, rather than writing every line of code manually. While this opens the door for broader participation, especially for those without deep technical backgrounds, Wood stressed the importance of understanding what the AI produces, mainly when financial applications are involved. Woods critiqued vibe coding, acknowledging its potential while stressing the importance of understanding the underlying code. When you're building blockchain apps, you're usually handling money. It's crucial to understand the code you're writing, Woods said. If you're vibe coding your way to blockchain-based apps, make sure you understand what comes out of the generative AI before you launch it into production. Despite these concerns, Wood sees vibe coding as a way to make blockchain development more accessible. Absolutely possible, he said of this approach on Algorand. We have plugins for VS Code that help you do all sorts of things, and they can definitely be extended to help you vibe code your smart contracts. Algorand's use of widely known programming languages plays a key role in this accessibility. We brought Python to Algorand, the same Python that's used for generative AI, the same Python that's taught in high schools and universities around the world today, Woods explained. Paired with TypeScript, this approach lowers the barrier for developers and improves AI-generated code. As Woods put it, not Python-like, not TypeScript-like, it's actual Python, actual TypeScript.